All right, so here we're going to be talking about a nitrile reacting with in acidic conditions, so H plus and water, which is different than basic conditions, which I'll show in a different video. So the whole idea here is that we can take a nitrile and turn it into a carboxylic acid in these acidic conditions, acidic catalytic conditions. So what do we know from the very beginning? We're going to have to add water twice because we're adding two oxygens. Right? We're going to lose a nitrogen. So how we're going to lose that is actually we're going to lose it as NH3 gas. Right? So and we're going to regenerate H plus catalyst. So let's get started. So the first step in these acidic conditions is always going to be protonation. Protonation is always going to be the first step. Alright, so now shown our protonated nitrile, this makes the carbon of the nitrile actually more electrophilic, not the nitrogen, right? Just because it has a plus charge doesn't mean it's electrophilic. Nitrogen is more electronegative than carbon, so actually this site is where it's electrophilic. And because water is on the bottom of the arrow, it's actually the solvent, so we have lots of water we can use here. So the first step is having that water, oxygen go there, the nucleophilic part of the water. It's going to form not a tetrahedral intermediate. All right, we went from sp to sp2, excuse me, I messed up there. There's no plus charge there anymore. The plus charge is actually going to be on the oxygen. All right, we can do a proton transfer. So this first step was we had a protonation. Then we had an addition. Got a proton transfer, which we can show if we want in an intramolecular sense. Oops. Giving that nitrogen the plus charge again. Now we can consider another water can come and react, right? Because again, because we've protonated this makes this carbon that much more electrophilic. So another water can come in. So following that addition of water, a second water, another addition there, we get to this kind of wicked looking tetrahedral intermediate. What we want to do, we know we're trying to get rid of the NH3, so we need to do another proton transfer. So do another proton transfer. This time I'll just save us the arrows and get us to the point where the nitrogen now looks like that really good leaving group we want. Always balancing our charge as we go. Now at this point, I can do it. I can this OH electrons go there to reform a pi bond. These electrons go there. That gets us to our NH3. The reason this is a one-headed arrow now because NH3 is actually a gas. So this will help drive the reaction forward. So that's the acidic mechanism turning a nitrile into a carboxylic acid. Oh, and one last step. This last step, of course, is an elimination step. Elimination step.